In this collab, I'm going to give a walkthrough of the sixth, which is Advanced Models Calls Back Tensor Board Submission. And I'm going to start by running the first code cell. So in this first code cell, I import all the required libraries, which are NumPy, Pandas, Matplot library, TensorFlow, and Keras. And I also set the mm, define some global configuration values like batch size, which we can see here, and some classes and input shape for the fashion MNIST image classification task. Next is data preparation. I will run this code cell. In this code, I load the fashion MNIST data set and normalize the pixel values by dividing by 255 so that all inputs are scaled between 0 to 1. And I then create like a split, validate, test splits, and everything. I add the channel dimensions to the image and create a TensorFlow dataset which batching and prefetching for efficient training. Next, I'll run the helper function. This defines the reusable helper function used throughout the notebook. The compile and train function compiles, trains, and evaluates a model where we can see plot history here, visualizes the learning curve, and other helper functions, summarizes and compare experiment results. Next is baseline CNN model. In this, I define a baseline CNN using convolution, max pooling, global average pooling, and dense layer. Then I train the baseline model on the training dataset, evaluates and plotted training and validation history. This baseline acts as the reference point for comparing the more advanced custom model later in the notebook. For now, we can compare between baseline CNN loss and accuracy. Next is custom layer, and here I define a custom TensorFlow layer that will be used in the advanced model. And the first custom layer adds Gaussian noise and for training for regularization. The second one is custom Monte Carlo dropout layer, which can also be used for different inference for uncertainty estimation. The third one is custom layer normalization layer that normalizes activation. Next is let's go for next cell and run this one. So in this cell, I define a custom residual block and then use it to build the advanced image classifier. Then the residual block helps the model learn deeper representation by adding shortcut connections. The overall model also includes a custom noise layer and custom normalization and custom Monte Carlo dropout. Next is learning rate scheduler and TensorFlow. Here I define a custom cosine learning rate scheduler callback. Then I create additional callbacks including tensor board for experiment tracking and model checkpoint for saving the best model. After that, I train the advanced custom model using these callbacks and plot its learning history. Yeah, so these are the two plots. Then I would launch the tensor board in Collab. So it helps visualize training metrics, validation, performance, and other logged information from the advanced model training. It is mainly used for better monitoring and experimentation tracking. So we can see. Next is Monte Carlo dropout inference. In this cell, I perform multiple prediction runs on the same test images using Monte Carlo dropout. Then I compute the mean prediction and also estimate uncertainty by measuring how much the prediction vary across. Next is here I display sample test images along with their true labels and predicted labels and the uncertainty value. This makes it easy to interpret the Monte Carlo dropout result visually and yeah. Next is in this cell, I compared the baseline CNN and the advanced CNN model using a summary table. In the last cell, I kind of visualize the comparison between the baseline model and the advanced custom model using a bar chart. The chart shows test accuracy, best validation accuracy, and overfitting gap side by side. Overall, in this notebook, I have built an advanced custom image classifier using residual blocks, custom layers, custom callbacks, tensor board, and Monte Carlo dropout for uncertainty estimation. Finally, both models are compared using evaluation metrics and visualization. That's it. Thank you.